The title of tonight's talk, you may have noticed in the pew leaflets that were distributed earlier, not tonight but before, began as being named. But the more I thought about it, the more the concept naturally evolved into who am I? And so I will begin by reflecting on the nature of our own experiencing of ourselves, also known in current literature as consciousness. I will refer to some experiments involving the human brain, including experiments relating to the phenomenon of the split brain, the two hemispheres that we have, and also the two systems of thinking that we have, one called, for simplicity's sake, System 1 and System 2. System 1 being the intuitive thinking that we all experience, off the cuff as it were, and System 2 being our more rational process of decision making. I will in passing say something about mindfulness, but ultimately I will return to ask what it is that makes us reflect on ourselves. Is it the existence within us of an intangible unitary spirit, or are we really simply a sum of our parts? In our belief system and spirituality, we often reflect on whether there is a place to which we will go when this earthly body of ours will have withered away. That question supposes, of course, that we exist apart from our earthly body, at least in some sense, and it is to the question of what the science says about the existence of that soul that I wish to turn attention tonight. I will, of course, be referring to authors and scientists, and I fully accept that in today's world, one finds scientists often for a variety of positions on most controversial topics. For now, you will have to rest with my assurance that I will be referring to people that I will identify, but they are mainstream thinkers, not fringe lunatics. What is consciousness? In her New York Times bestseller, Conscious, A Brief Guide to the Fundamental Mystery of the Mind, the author Annaka Harris, married to Sam Harris, speaks about how as a child she remembers lying down on the earth with her arms spread widely and looking up at the sky and realizing that her feeling of being down here on the earth and the sky being up there was not an entirely accurate perception. After all, she explains how she was intrigued by the fact that as a collection of matter, us human beings were pulled down onto the surface of the earth by gravity, but that the earth itself was of course orbiting the sun, and the sun in turn was moving because the universe, we are taught, is expanding, not yet contracting, and that the sun was part of a solar system of which there were billions and billions in the universe. And so the notion of being down here and the sky above there is wholly wrong. All we can really say is that as human beings, we are part of matter in an incomprehensibly expanse of matter, in which it would be entirely wrong to speak of something which is up in the sky or down on earth. But what the story of Annaka Harris indicates is an experience of a human being already at childhood of awareness or of consciousness. Harris says that the most basic definition of consciousness is that given by the philosopher Thomas Nagel. I have referred to him in one of the talks we had here, in his famous essay, What is it like to be a bat? Thomas Nagel, incidentally, is still alive. He must be in his early 80s, born 1937. He defines consciousness like this. He says, quote, an organism is conscious if there is something that it is like to be that organism. So we might ask, is it like something to be you this very moment? And if I should pose that question to any one of you, you would certainly respond affirmatively. But if I were to ask you whether it is like something to be the chair that you're sitting on, your answer is likely to be a firm no. And so we might extend our investigation by asking whether it is like something to be a grain of sand. No. A cat? Probably yes. A bacterium? Probably no. An oak tree? I wonder. A mouse? I think so. A dog? Certainly our dogs. And we may therefore accept fully, as a particular form of matter in this universe that constitutes the evolved ape, that we are made up of matter which experiences fully what it feels like to be something. So this ability to experience what it feels like to be something, is that just another way of saying we have a soul? Does this evolved ape therefore have the distinct characteristic of being possessed of a soul? Let's start with where consciousness begins. We know that certainly a human being in its most basic form, a blastocyst of only a few days old, consisting of about 200 cells, likely does not experience that it is like something. So if experience and being something that it is like to be that organism is just another way of saying that it is the human soul, then we know at least that the human being in its most basic form does not yet have a soul. But we know that over time those 200 cells multiply and slowly they become a human baby with a human brain, able to detect changes in light and to recognize its mother's voice even while still in the womb. And unlike a computer that can also detect changes in light and can also recognize voices, this incipient human being is beginning to experience something that it is like to be that being. So what has happened here? Was there a magical moment at which a soul was implanted in that developing physiology? Or has something else happened at that moment when energy sprang into existence in that otherwise mere collection of matter? The Australian philosopher David Chalmers termed this question as the, quote, hard problem of consciousness. So the hard problem lies in understanding why some of these physical processes have an experience associated with them at all. But is consciousness just an illusion? Anna Buckley of the BBC Science Radio Unit recently discussed a view expressed by Daniel Dennett, a cognitive scientist, who says our brains are machines made up of billions of tiny robots, our neurons or our brain cells. It is in a well-known but infamous memorandum written in 1965, the philosopher Hubert Dreyfus stated that humans would always beat computers at chess because machines lack intuition. Daniel Bennett disagreed. A few years later, Dreyfus found himself, rather embarrassingly, in a checkmate situation with a computer. In 1997, the IBM computer Deep Blue defeated world chess champion Garry Kasparov. So Dennett, in an interview with BBC Radio 4, The Life Scientific, says that there is nothing special about intuition. He says intuition is simply knowing something without knowing how you got it. He blames the philosopher René Descartes for permanently polluting our thinking about the human mind. Descartes could not imagine how a machine would be capable of thinking, feeling, and imagining. But, says Dennett, our brains are made up of 100 billion neurons. If you were to count all the neurons in your brain at the rate of 1 a second, it would take more than 3,000 years to count your neurons. Dennett says consciousness, therefore, is real. We experience it every day. But for Dennett, that consciousness is no more real than the screen on your laptop or your smartphone. He says that pressing the icons on our smartphones makes us feel in control of the hardware inside. But what we do with our finger on a smartphone is a pathetic contribution to the sum total of smartphone activity. And of course, it tells us absolutely nothing about how a smartphone works. Human consciousness, says Dennett, is exactly the same. We know that we have evolved from the apes, and we know that we share 99% of our DNA with chimpanzees. We acknowledge that some of our behavior is due to our animal nature. Our more special qualities like intelligence, insight, and creativity, we like to think, must have more special causes. But our brains, like our bodies, have evolved over hundreds of millions of years. They are the result of millions and millions of years of haphazard trial and error evolutionary experiments. Consequently, our ability to think is no different from our ability to digest. We evolved from uncomprehending bacteria, and our brains, with all their remarkable talents, are the result of endless biological experiments. Dennett argues that Descartes grossly underestimated the machines that we are, but the mathematician Alan Turing set him right. He predicted that by the end of the previous century, the use of words and general educated opinion will have altered so much that one will be able to speak of machines thinking without being contradicted. And so before turning to some experiments on the split brain, want to make a remark about the boundaries between science and religion, and to ask the rhetorical question whether there is scope creep. Is science scope creeping onto the jurisdiction, if you will, of religion? I suggest that science generally, including the science of the mind, has evolved so much and continues to evolve at such a speed that just as the science of information technology has exploded in the past century, that we have to revisit well-trodden assumptions about the soul. For example, young earth creationism is a form of creationism that holds that the earth and its life forms were created in their present form by supernatural acts of a deity between approximately 6,000 and 10,000 years ago. It is based on the religious belief in the immutable accuracy of the literal interpretation of the book of Genesis. Its primary adherents believe that the earth was created in 6 days. Of course, there are many that believe that the concept of days should not be seen as limited to 24 hours. And many believe that science has proved incontestably that those 6 days are merely mythological. But if the period of 6 days in Genesis is merely mythological, and has been rendered mythological by the inexorable advance of the boundaries of science, what else in what we read and what we know has been rendered mythological by advancing science? And so now I turn to interesting experiments on the brain. In the field that we're discussing tonight, Roger Sperry won the 1981 Nobel Prize in Physiology and Medicine for his work in split brain research. His work inspired a literature, according to Sam Harris, Annika's husband, in his well-known book, Waking Up, that spans neuroscience, physiology, linguistics, psychiatry, and philosophy. For a considerable period of time, scientists have known that the human brain consists of two hemispheres, the left and the right. These hemispheres are connected by several nerve ducts, the function of which is at least to pass information back and forth between the two hemispheres. The functional unity of every human brain depends upon the normal functioning of these connectors. Certain patients, particularly those with epilepsy, have had these connectors between their forebrains severed. The object of this procedure is to prevent local storms of unregulated activity from spreading throughout the brain and producing a seizure. And so once these patients have recovered from surgery, they generally appear quite normal, even upon neurological examination. However, Roger Sperry devised experimental conditions which showed that although the left and the right hemisphere of the brain displayed a high degree of functional specialization normally, in those that have had the surgical split, the range of segregated abilities were displayed more markedly. What Sperry also illustrated was that where the forebrain connectors were cut, these two hemispheres displayed what has been described as an altogether astonishing functional independence. This included separate memories, separate learning processes, separate behavioral intentions, and, important for tonight's discussion, separate centers of conscious experience. Scientists know that the split brain phenomenon is well illustrated by the fact that everything that falls in the left visual field, left eye, is projected to the right hemisphere of the brain, and everything in the right visual field is projected to the left hemisphere. This pattern holds also for both sensation and fine motor control in our extremities. This means that each of the two hemispheres relies on intact connectors between the two hemispheres to receive information from its own field of the world of observation. And while the right hemisphere cannot speak, because speech is confined to the left hemisphere, the right hemisphere can respond to questions by pointing to written words and objects with the left hand. And so the classic demonstration, experiment, of hemispheric independence in a split-brain patient works this way. Show the right hemisphere a word, say egg, by briefly flashing it in the left half of the visual field. And the patient, speaking from the language-dominant left hemisphere, will claim to have seen nothing at all. Ask him to reach behind a partition that you set up and select with his left hand, which is dominated and controlled by the right hemisphere, the thing that he claims he did not see. And he will successfully pick up the egg among a multitude of objects. Ask him to name the item he now holds in the left hand without allowing the left hemisphere to look at it, and he will be unable to reply. If shown and asked why he selected it from among the available materials, he will confabulate an answer, he'll make up an answer. So there are other features that the science of neuroexamination have taught us. People usually show a right ear, left hemisphere advantage for words, digits, Morse code, and difficult rhythms. On the other hand, they show a left ear, right hemisphere advantage for melodies, musical chords, environmental sounds, and tones of voice. We know too that the right hand, whose sensation projects almost entirely to the left hemisphere, is better able to discriminate the order of stimuli, whereas the left hand is more sensitive to their spatial characteristics. We know further that the right hemisphere is dominant for many higher cognitive abilities, both in normal brains and in split brains. The right hemisphere tends to have an advantage when reading faces, intuiting geometric principles and spatial relationships, perceiving wholes from a collection of parts, and judging musical chords. The right hemisphere is also better at displaying emotion with the left side of the face and at detecting emotions in others. There are even signs now that suggest that the two hemispheres differ in temperament, and it appears uncontroversial that the two hemispheres can make different and even opposing contributions to a person's emotional life. In a split brain, the hemispheres are unlikely to perceive self and world in the same way, and they are likely to feel, nor are they likely to feel the same about world and self. Scientists also know now that much of what makes us human is generally accomplished by the right side of the brain. Inferentially, the disconnected right hemisphere is independently conscious, and the split brain therefore harbors two distinct points of view. What is the impact of split brain research on the existence of the soul? Where do these observations lead us in considering the existence of a unitary soul? It certainly leaves a huge problem, as far as I'm concerned, for the notion that each of us has a single, indivisible self. The very idea of a soul arises from the feeling that our subjectivity has a unity, a simplicity, and an integrity that must transcend the physiology of the material body. What makes the split brain research interesting and what it has shown is that subjectivity can quite literally be sliced into two. Makes you think, doesn't it? Moving on, Daniel Kahneman was awarded the Nobel Prize in Economics in 2002. In his international bestseller, Thinking, Fast and Slow, he explains that our minds have two functional systems, which he simply describes as System 1 and System 2. System 1 operates automatically and quickly, with little or no effort and no sense of voluntary control, one might say intuitively. System 2 allocates attention to the effortful mental activities that demand it, including complex computations. The operation of System 2 is often associated with the subjective experience of agency, of choice, and of concentration. A good example he gives to athletes like Ken is he says, try when you're jogging slowly to solve a complex problem. and you might be able to do so while you're jogging slowly. But the moment you start jogging fast and you're expending energy, the energy that your system 2, not your intuitive system, your rational system, requires to resolve that problem is sapped away from your brain. Your system 2 has been shown to be demanding of glucose, and you can't work out a complex problem when you're running fast. Another good illustration of the difference between system 1 and system 2 is the quick question of a bat. It's an American book, so speak an American language. A bat and a ball, which costs $1.10, and together, and the bat is $1 more expensive than the ball. What is the price of the bat? Your intuitive system 1 will say $1. Of course it's not. So the moment you stop and you reflect and you engage system 2, spending more energy, you realize that the difference is 105 and 5, else the sums don't work out. The one is not $1 more than the other. But the automatic operations of system 1 may generate a complex of ideas, but only the slower process of system 2 can construct thoughts in an orderly series of steps. In his book, he describes the interaction between these two systems. Both systems are active whenever we are awake. System 1 runs automatically, and system 2 is normally in the low effort mode, in which only a fraction of its capacity is engaged. When all goes smoothly, system 2 adopts the suggestions of system 1 with little or no modification. You generally believe your impressions, and you generally act upon your desires. We build our reasoning and conclusions and our rationality upon our intuitive thinking. And usually that is fine, until the complex problem requires the engagement of system 2. The point about all of this for tonight's discussion is that the notion that we have a singular, indivisible unit of sense and feeling has been illustrated to be fundamentally wrong. Where does mindfulness fit into the bigger picture? The Dalai Lama said, quote, "There are only 2 days in the year that nothing can be done. One is called yesterday, and the other is called tomorrow. So today is the day to love, believe, do, and mostly live." But mindfulness conceptually is more complex. It engages the discipline, therefore in the language of Kahneman, of system 2, to bring about an awareness of the here and the now. Of this condition, Sam Harris says, quote, "It is always now. This might sound trite, but it is the truth. It's not quite as true as a matter of neurology, because our minds are built upon a layer of inputs whose timing we know must be different. But it is true as a matter of conscious experience. The reality of your life is always now, and to realize this is liberating. In fact, I think there is nothing more important to understand if you want to be happy in this world," says Harris. With respect to the great neuroscientist and author, these comforting words, I think, roll easily from the lips of the privileged. If your life is a living hell, the here and the now is the last place you want to be. Then living in the yesterday or in the tomorrow is where you want to be. But the relevance of this observation goes to the functioning capacity of our minds to take us to places of comfort, perhaps assuring us that we have a soul that is guaranteed salvation. But it is incapable, I suggest, of denying the physiological reality of the brain and its essential capacity for conscious thought, and it being the foundation of both systems 1 and 2 of our reasoning processes. Temporary places of illusionary escapism, I suggest, are just that, temporary and illusory. Ultimately, the here and the now is unavoidably under our noses, forcing our brains into system 2, demanding effort, rationality, and solution. So, who am I? I suggest the answer is within each of us in every sense of the phrase. We are the sum of our parts, magnificent parts, evolved over an expanse of time, make no mistake about it. but no more than an aggregation of billions of functioning cells.